Let's begin. Today's September 26th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 1, 7, 10, 14, 18, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and compares it to the number 1. So should triangle be equal to 1, or should triangle be greater than 1? Criteria card B looks at our last digit, the circle digit, and will let us know which one, or whether it's an even digit or an odd digit. Criteria card C will take a look at our 3-digit solution and will let us know how many of those digits are 4. Are there no 4s? Is there a single 4? Perhaps 2, maybe even all 3 are 4. Criteria card D will look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card E again looks at our 3 digits, triangle, square, and circle, but this time it'll add them up and will let us know if the sum total is an even quantity or an odd quantity. And finally, criteria card F again looks at our 3 digits from triangle to square to circle and will let us know a little bit about the ordering of the digits. Are they in ascending order, meaning that they're increasing, as in the example 135, or are they in a descending order, or decreasing, as in the example 421, or could it have no order? So let's look at the example of 231. Notice it goes from 2 to 3, which is increasing, and then 3 to 1, which is decreasing. That shift is one way to describe a 3-digit code as having no order. Other puzzles have had examples where if you have 2 consecutive equal digits, that also exhibit no order. So for example, if you have 225, when you go from 2 to 2, there's no change. So that's another way that you can describe a 3-digit code as having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that last digit, the circle digit. So let's go ahead and test criteria card B. Okay, so the Turing Machine approves of my choice. I did pick an even 4, so the Turing Machine is confirming, yes, circle is even. So let's go ahead and type that up in our notes in section B. And that again is that circle is an even digit. And since it is even, let's go ahead and cross out all the odds. Okay, the next thing I think I'd like to test is criteria card E. Okay, so again, the Turing Machine approves of my proposal. Notice in criteria card E, we are adding the 3 digits up. So let's go ahead and do that. So 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity, and as the Turing Machine confirms it, yeah, that means that some of the 3 digits must be an even digit. So let's go ahead and type that up in section E. So triangle plus square plus circle should be an even quantity. And since it is an even quantity, let's take a look. So we already have a circle as an even digit. So what that tells us is that triangle and square must be of the same type, meaning they're either both even or both odd. Because in either case, when you add up two evens or two odds, that sum at that point is even. And if you want the sum total to remain even, you're going to add an even to it, which would be our circle. So we're looking for a solution that is odd, odd, even, or perhaps all even. And in either case, you could have a pair, possibly. We just don't know yet. Now, it is interesting that we do have criteria card C, which lets us know how many 4s there are. So at this point, anything's, well, we know you can't have 3 4s because you do have an absolute smallest. And not to say that that's a clue as well, but typically if you do have two digits that are paired up, there's always going to be a smaller digit or a larger digit. But in this case, our criteria card D is focusing on the fact that there is a smaller digit. But again, that doesn't mean that you necessarily do have a pair of digits. Let's see, what else could we test? So we're trying to figure out, let's see, what would it mean for there to be 2 4s or no 4? If we have 2 4s, then we know the other digit would have to be a 2. Because if you have 2 4s, you need a third even. That's a possibility. If you have no 4s, then we know circle would be 2. So I'm just wondering. And also we do have an absolute smallest digit. Let's see. So I don't think you can, okay, so I don't think you can have 3 4s because of course you do need a smallest. And I also don't think you can have 2 4s because I believe, as I mentioned earlier at the top of the video when discussing criteria card F, if you have 2 equal digits, consecutive digits, that could have no order. So for example, if you had, say, 4 4 5, that's no order. If it's 5 4 4, that's no order. And if you had, say, the 4s as triangle and circle, like 4 2 4, that's no order. So I think for that fact, and I hope that's somewhat clear, that you can't have 2 4s. So I think at this point it is a 50-50. Do you have a 4 or not? And so I think I'm going to test C. And if I do have a 4, and I do have one in my proposal, that's awesome. And if not, then we know our C has to be 2. So let's go ahead and test criteria card C. Okay, so we do have a single 4. Now, let me type that up. So we'll just say that the solution has a single 4-digit. Okay, so we know we have a single 4. Remember, so the 4 is not paired up. Oh, so this is interesting. The 4 is not paired up. And we just said, wait, could that possibly be it? If we have a single 4 and it's not paired up, that means that has to be the smallest. Can that be the solution? 554? We have only one 4. And remember, the non-paired up... Wait. I apologize. I'm getting ahead of myself. There's no indication that you necessarily have pairs. The only thing that criteria card C is leading us to is that you have 2 of the same. Yeah, 2 of the same. I apologize. Okay, so we do have a 4. So can we say, let's see, can we say for short circle? Can we eliminate, again, there's no indication that there's a pair necessarily. It's possible, but can we somehow eliminate all 2s altogether as well if you have a 4? So you don't have 2 4s. You only have 1. And yeah, I think you can eliminate all the evens, except for 4, of course, because otherwise you'd have to have 2 2s, and that would not allow for the smallest. Yeah, surprisingly, I think we can say that circle has to be the 4, because there's no way you could have 2s. Yeah, you can't have 2 2s because they wouldn't be the smallest. Yeah, so I think we can eliminate all of the 2s as well. And so circle has to be the 4, and triangle can no longer be a 2 or a 4. That is very interesting. Only a single 4, and you cannot have any 2s, because then they would have to be paired up for the sum total to be even, and that's not possible because they wouldn't be the smallest. Wow, what a incredible discovery. Okay, so we are dealing with odd, even, and we have a 4, and we're done for this round. We've completed our 3 Turing tests. So now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing triangle to the number 1. And we also did not test criteria card D, which one is the absolute smallest. And of course, there's the ordering of the digits. And we don't know exactly what the ordering is. I don't think we've concluded anything from that. But we know that the smallest has to be an odd, and it's either going to be triangle or square. Again, you could have the possibility where it's 554, as I mentioned earlier, but that was, I was going on the basis that you had pairs, and there's no direct knowledge of that. So let's see. Can we have? Well, it'll be interesting. Let's see. What can we do with a 4 circle? I don't, yeah, I guess we could have a descending. You could have 1, 3, 4. You can't have, I mean, ascending. I apologize. 1, 3, 4 is ascending. You can't have descending because, if you start off at 5, then the only option would be a 1 or a 3, and then you'd pivot back. So it's either ascending or no order. And, the odds are that it's going to be no order because there's more to pick from, and these cards tend to eliminate certain possibilities. So what if triangle were 1 and it'd be no order, so it'd be 1, 5, 4. Let's see. If we have, yeah, that's what I'm kind of going with. 1, 5, 4. So, yeah, it could be, triangle is 1. Yes, that's the smallest. That eliminates square being 1. And we want it to be no order. Yeah, let's go with that. Now, obviously, the other obvious possibility, though unlikely, is that, we did get 3 checks. Could the solution actually be 3, 1, 4? It's possible, but unlikely, because that would mean that square is the smallest. And how would you pick between 3 and 5? So I don't think that's going to be it. So I really do believe triangle is going to be the smallest. And then it would be 1, 5, 4. So let's see, will we be able to deduce anything? Maybe. Okay, but let's go with 1, 5, 4. Okay, so the whole point, well, let's see. Yeah, because I guess you could have, that's bigger, but you still want, yeah. Yeah, let's go ahead and test criteria card A. Okay, so yes, triangle is equal to 1. Okay, and so of course that can be a 3 or a 5. And I think it's safe to say that triangle has to be the smallest. So I think we can deduce that triangle is the smallest. Because you can't even have 2 1s. So I think you can cross out the 1. And we're gonna deduce, I'm gonna type it up as we're deducing that triangle is the smallest. So we're gonna deduce triangle is the smallest. And so now all we have to do is really test criteria card F. Okay, fantastic. Yeah, the solution has no order. And so what does that mean? So yeah, it can't be 1, 3 because that would be ascending. So it is 1, 5, 4. Okay. So let's type that up as 1, 5, 4. Okay. And yeah, I think we've got all those check marks, so it must fit the bill. And of course, we did deduce criteria card D. So let's confirm that our solution is 1, 5, 4. Okay, fantastic. Well, how do we do versus the Turing machine? Well, we got all checks, so that'll be easy to type up. We did BCE in the first round and then AF in the second. So BCE, BCE, and then second round AF. And we deduced D, the smallest. So how do we do? Okay, so we only beat it by one. I was really thinking that we're going to beat it by a little bit more just because, we did deduce outright criteria card D. And then, just the revelation of how criteria card C played out in round one, where we were able to eliminate all the twos and the remaining fours except for circle. I was really thinking we would have won by at least two, but okay, that's okay. But still an extraordinary, like I said, I'm still pleasantly surprised how criteria card C played out. I thought that was extraordinary. And I've mentioned in previous puzzles how combinations of cards sort of reveal these insightful concepts of the structure of the three-digit code. Just really, that's what I really enjoy about this game, that discovery. So I hope you did too. What did you think? How did you solve? Did you do a different set of criteria cards yet still came to the same conclusion? What did you notice about the video? Add those ideas to the comments. Give it a thumbs up if you enjoyed the video, and of course make sure to hit subscribe so that you're notified of any future videos. Well, until next time, have a great one.